This video covers Part 1 of Lesson 2-10 for Secondary 1 Math, Writing and Graphing Linear and Exponential Equations. This lesson focuses on a specific exponential formula called the compound interest formula. And here we can see the compound interest formula is written as A equals P times 1 plus R divided by N raised to the NT power. Well, what do these things mean? First, let's start with P. P is our initial value. Sometimes we call it the principal amount, or sometimes we'll say it's the investment. Next, we have the R. The R is our interest rate, so this will be our percentage. Then we have N. N is the number of times the investment is compounded in a year. So here's N. Notice it shows up twice in our compound interest formula. So we're going to put it in both of those locations. And we'll talk more about N in just a second. T is the number of years the investment is left in the account to grow. Now this is super important. There's an extra bullet point here, right here, super important. T is always in years. And notice, just like with our exponential equations, T is our exponent. Time is our exponent. And then the last thing is A. And A is our total value. That's after the T years, or our account balance. And that's here. So we're going to use this formula, and we're going to just substitute in values and find out how much people are saving over a certain number of years. And this formula is the compound interest formula. Now, back to N. We know that N represents the number of times the investment is compounded in a year. And we're going to see certain words that are going to help us identify when or how often it is. If it says yearly or annually, right here in our table, then it's only happening once a year. If it's semi-annually, that would be 2 times a year. Semi meaning 2, or half. Quarterly, that means there's 4 times. Monthly, well, there's 12 months in a year, so that'd be 12. Weekly, 52 weeks in a year, so 52 times compounded. And daily would be 365 times a year. So remember, this is N. We're looking for N, the value of N. And we can refer back to this table, and we're going to again and again as we go through these different problems. All right, and this is key here. It's bold on your notes. You only use the compound interest formula if the problem has the word compounded in it. So it's got to say compounded somewhere. So let's take a look at our first example. An investment of $500 is compounded monthly at a rate of 3%. So let's identify a few things. The first thing, let's identify our principal. Well, that's the investment that they made. So our P is equal to 500. Now R represents our rate. And right at the end here it says the rate of 3%. And just as we've done with our exponential equations and the equations we've done before that, our inequalities with percentages, we always convert our percentage to a decimal. So R is 0.03. Now the N. Remember, N is the number of times it's compounded in a year. And here it says it's compounded monthly. And there are 12 months in a year, so N is 12. Number 2, write the equation to represent the amount the investment is worth after T years. So we know T is a variable. We're also going to have A as a variable. And our compounded interest formula is A equals P times 1 plus R divided by N, all raised to the NT power. So we're going to substitute in what we already know. And we get A is equal to our principal, which is 500, times 1 plus r is 0.03 to over 12. Close our parenthesis, and then we have 12t. And this is our equation to represent what this investment is worth after a certain number of years t. Now we're going to use that equation and fill in our table and graph what we find. The equation A equals 500 times 1 plus 0.03 over 12 raised to the 12t power. So we're going to substitute in 0 for t, which makes everything in the parentheses simplify to 1. And 1 times 500 is 500. So at 0 time, or 0 years, we have $500. Which makes sense. If you invest $500 and no time has passed, you have $500. Let's take a closer look at this next one and how we would use our calculators to help us do it. So we're going to substitute 5 in for t. So we're going to have in our calculators 500 parenthesis 1 plus 0.03 divided by 12, close your parenthesis. Then you use the caret symbol, which gives us our exponent, and then you're going to put parenthesis 12 times 5 and close your parenthesis. If you don't put the 12 times 5 in parentheses, then it'll actually raise it to the 12th power and then multiply that by 5 instead of raising it to the 12 times 5 power. And when we put this into our calculators, we end up with 580.8. But notice at the top of that second column, A needs to be rounded to the nearest whole dollar. So we're going to round to the nearest whole dollar. So that would be $581. And then we're going to continue this process, and we're going to write it out. We would have 500 parenthesis 1 plus 0.03 divided by 12, close your parenthesis, and raise that to the 12 times 10 in parentheses. And when we put this into our calculator, we find that it is 674.67, and it continues on from there. We'll round it to the nearest whole dollar. That would be $675. And then we're going to continue this, substituting in 15, and then 20, and then 25, and then 30, and then 40, and 50, and 60. And so when we substitute in 15 and evaluate this formula, we end up with, rounding to the nearest dollar, $784. Well, when we substitute in 20, so this is 20 years, after 20 years it will have $910. After 25 years we would see $1,058. And after 30 years the account balance would be $1,228. After 40 years the account balance would be $1,658. And after 50 years, it would be $2,237. And after the 60 years, it would be $3,018. Now remember, we're rounding all of these to the nearest dollar. Now that we've filled in our table, we can take each row across and plot that point on our coordinate plane. But before we do, let's go ahead and label our axes. The x-axis, or we could call the t-axis, is the number of years, and the y-axis is the account balance, and of course the account balance is in dollars, so we're going to put in dollars. Now we'll plot our points. So the first one is 0, 500, so I'm going over to 0 and up to 500, and that's halfway between 400 and 600, and that will be on our y-axis. The next one is 5, 581. So I go over to 5, I go up, 581. Still a little less than 600, but a little higher than before. Next up, we have 10, 675. So we go right 10 and up to 675. So maybe about here. Next up, we have 15, and so going right 15 and up 784, just less than the 800. And we're going to continue to plot these points so that it ends up looking like this graph. And notice it has a curve to it, and that's because this is a type of exponential function or exponential equation when we graph. Okay, next situation. An investment of $1,000 is compounded semi-annually at a rate of 4.7%. So first we're going to identify our principal. This is number 4. Principal P is always the investment, what we're putting in. So this is going to be the $1,000, or 1,000. Then we look for R, and that's our rate. At the very end, the rate is 4.7%. Remember, we always change this to a decimal, so we're going to have 0.047. And then last, we have N. And N is the number of times it's compounded. And it says compounded semi-annually. So since it's compounded semi-annually, that means twice a year. So N equals 2. Number 5. Write the equation to represent the amount the investment is worth after T years. So we're using that same compounded interest formula. And we're just going to substitute in what we know from the situation. So we have A is equal to our principal, or P, which is 1,000, times 1 plus our rate, which is 0.047, divided by the number of times it's compounded in a year, which is 2, and we're going to raise it to the NT, so our number of times compounded 2 times T. And there's our equation. Now, using that equation we just found in number 5, we're going to substitute in the values for T, which are on the left side of our table, and find A, or the account balance after that many years, rounding to the nearest dollar. When we substitute in 0 for T, remember that turns our exponent to 0, which brings all the parentheses, everything inside there, 1. And 1 times 1,000 is 1,000, or it just gives us our initial investment, or initial amount. When we substitute in 10, just like we did before, we're going to take that 1,000, we're going to multiply it by 1 plus 0.047 divided by 2. This is in our calculators, and then the caret symbol, raising it to the power, parenthesis 2 times 10, or you could just write 20. And when we put that into our calculators, we get 1,591.3. Rounding to the nearest dollar, that would be $1,591. And we're going to continue that process just as we did on the situation before this, where we just substitute in the T value, evaluate, get our A value, or the account balance. So after 20 years, the account balance would be $2,532 when we round to the nearest dollar. When we substitute in 30, we're saying after 30 years, our account balance would be $4,030. After 40 years, so substituting in 40, we would get $6,430 as the account balance. And after 50 years, it would be $10,204 in the account. And after 60 years, our account balance would be $16,238. After 70 years, it would go to $25,840. And after 80 years, the account balance would be $41,120. Now that we've filled in our table, we're going to go ahead and graph this. So our X and Y axes, or our T and Y axis, are always going to be labeled the same. Our X will always be the number of years. And then the Y-axis will be our account balance in dollars. So we'll go ahead and graph what we have here. So 0 and 1,000, so halfway up there. And then we have 10 and 1,592, so getting closer to the 2,000 mark. Then at 20 we have 2,532, so over to 20, up 2,532. Then over 30 and up to 4,000 in a little bit. And we're going to continue to plot these points, and then we'll connect them, making a curve to represent the growth of the account balance. So our graph would end up looking something like this. Now if you haven't paused the video and do it yourself. Make sure you're plotting those points, and it should look something like this. Okay, our next situation. An investment of $600 is compounded quarterly at a rate of 12.9%. In number 7, we're asked to find P, or the initial value, R, or the rate, and N, which is the number of times it's compounded in a year. So let's begin with P. Well, we know that we invested $600, so that would be our P. Then we know that the rate is our percentage, so the rate is 12.9%, or as a decimal, 0.129. And N is the number of times it's compounded in a year, and it's compounded quarterly. And there are 4 quarters in a year, so N is 4. Now we're going to go ahead and write the equation to represent the amount the investment is worth after T years in number 8. So remember, we're referring back to this compounded interest formula, and we're going to substitute in the values we have written in number 7. So pause the video and try it. So hopefully you have it on your paper. And remember that our formula is A equals P times 1 plus R over N, close your parenthesis, that being raised to the N T power. So substituting in, we get that the account balance A is equal to 600, parenthesis, 1 plus 0.129 divided by 4, and we're going to raise that to the 4T power. Now that we've written an equation to represent the amount the investment is worth after T years, we're going to use that equation to fill in this table in number 9 and create a graph. Remember, to do this, we're going to take our formula, we're going to substitute in the value of T into it and come out with a value for A. And we're going to round that to the nearest whole dollar. So go ahead and pause the video and fill in your table, and then start the video and check your answers. So once you've filled in your table, it should look like this. You should have at 0 years 600, after 2 years 773, after 4 years 997, after 6 years 1,285, after 8 years it would be 1,657, after 10 years 2,136, after 12 years 2,753, and after 14 years 3,549. So now we're going to go ahead and graph these points. Remember to label your axes first, so our x-axis will label years, and the y-axis will label our account balance in dollars. Now that we've labeled our axes, we're going to go ahead and plot our points, and our first point is 0, 600, so we're going to go on the y-axis and plot a point at 600. Now pause the video and finish the graph. Now your graph should look something like this. Now your points may be slightly different just because the scale on our y-axis is so large. But there's our graph. This concludes the Part 1 video of Lesson 2-10 for Secondary 1 Math, Writing and Graphing Linear and Exponential Equations.